It's actually a pretty good video.
Data update. The traditional way to write the Fibonacci is to take a temporary variable for y, add up your new y, and then use your temporary variable. I hate this code. I've written code like it a lot of times because I started with a 1967 version of Dartmouth Basic, and it was all I had. But there's a better way. You can use the tuple packing and unpacking. Don't overlook how important it is. It's profoundly important. The problem with that, okay, well, first I'll show you the correct solution. The correct solution, the way you'll often see it written, is with simultaneous variable updates. The y and the x plus y use the old values of x and y to build the tuple. Then they get unpacked and stored in the variables. The x and y are state. The state should be updated all at once. If you don't update the state all at once and put it on multiple lines, in between those lines, the state is currently mismatched. At one point, y is the new y and x is the old x. This is a very common source of problems. And plus, the ordering matters here. If I muck
Thankfully,
up the
I'm
order
across
of
the
these
street from
three,
a library. If it
it
wasn't
breaks
for
the
that, I don't
code,
think
and it's
I'd
a
be able
hard
to
error
digest
to
this all.
see. The last thing I don't like about it, besides the risk of order, is it's too low level. On the next slide, I'll talk about taking an atom and breaking it into subatomic particles. This has been broken into subatomic particles. What does this say? This says take y and store at t, x plus y to y, and t to x. The second one says update these variables according to those equations. And so you transform one to the other. The second way is a higher level way of thinking. It doesn't risk getting the order wrong, and it's fast in Python. Please transform code like that into this. Lest I let that go, it's got a whole additional slide and a half, okay, 2 slides for this. This is such an important product. Don't getting atomic particles. This is state. The state should be updated all at once. If you don't update the state all at once and put it on multiple lines, in between those lines, the
So then we have that here somewhere. Let's go. Well, this is actually a lot more uniform. But we'll see what his looks like. Alright, see, missing required argument in. Alright, prime range in print x. Oh, okay. So let's add a n equals x plus 1, x, y. Oh, that's equals. There we go. Missing an argument for n. Let's try this. Alright, so we can print 10 that way. Or we could do n if we wanted to, and then supposedly oh, duh. Not sure actually if that's correct. Probably is just better to do that. Okay, let's see here. So, oh, duh. Or it. Actually, we want my dyslexia. Okay, there we go.
State is currently mismatched. At one point, X, Y.
There we go. So that would be the correct way to do that. And receive an input.
Y
You don't
is the
need to
new
receive
Y
input.
and
You
X
could
is
just
the
put
old X.
your
This
own
is a
argument
very
there
common
for
source of
the
problems. And
for our
plus, the ordering
purposes.
matters here. If I muck up the order of these three, it breaks the code, and it's a hard error to see. The last thing I don't like about it, besides the risk of order, is it's too low level. On the next slide, I'll talk
So
about
he's gonna go
taking an
better.
atom and breaking it into subatomic particles. This has been broken into
Whatever
subatomic
about
particles.
atoms.
What does this say? This says take y and store at t, x plus y to y, and t to x. The second one says update these variables according to those equations. And so you transform one to the other. The second way is a higher level way of thinking. It doesn't risk getting the order wrong, and it's fast in Python. Please transfer subatomic particles. This has been broken into subatomic particles. What does this say? This says take y and store at t, x plus y to y, and t to x. The second one says update these variables according to those equations. And so you transform.
Oh, so that one I gotta make sure works for me too. It didn't work earlier because I was too lazy to do it, but we'll go Fibonacci. We'll go let's go example 1, example 2, and then we will fix this here. Alright. I went to the library the other day, grabbed myself a beginning, because I don't really know this stuff that well. I kind of grasp it, but I'm like hanging in there, you know what I mean? So I went to the library and grabbed myself a couple of books on calculus and Java and stuff like that. So I'm gonna give it a swing, see what I can't do here in a couple of months of just consistent learning, consistent lectures, videos, that whole business, because this is completely self-taught. I'm not going to do any classes outside of this. I'm not going to school for this, and I just want to sort of see what a regular person can accomplish by just jumping into this and trying to learn the best I can. So that's my goal here. I really believe anybody can do this if they really desire to. I know a lot of people that want to develop games and friends of mine that are really interested in doing this stuff. So I think if they see that, it's possible with just a little bit of learning and consistent work and effort, you won't just be printing letters on a screen. Eventually, you'll have a world and a guy and a ball bouncing on the screen or whatever you want to do. So this is really the boring part of it. Of course, nobody likes to really spend hours trying to figure out ways to add x and y to each other, but I think this could be a really awesome project if it gets consistent and we have a lot of videos here that can actually continue to teach us proper code, because the problem I'm finding is that there's just people out there that don't know what they're doing and they're teaching people how to do something, and not necessarily that it's the wrong code sometimes, but just the fact that it's for the wrong version of Python or whatever language you're using. I'd really, if I knew this stuff well enough, I'd like to figure out where the good references were so I could help people in that way, but I'm going to be beginning here, so everybody bear with me.
From one to the other. The second way is a higher level way of thinking. It doesn't risk getting the order wrong, and it's fast in Python.
This guy's the
Please
expert,
transfer
though. He's
one
actually
code like
taught me a
that
lot of
into
what I know
this.
right now.
Lest I let that go, it's got a
Actually, no, I know a lot about languages and programming, but, just like every other guy that isn't a master, you're stuck going back to documentation and references, and a lot of the code that you do can be simplified, unless, you really mastered the language. Most of the time, if you're doing something, and you're just getting the grip, you could look at your code and see that it could be simplified, and you almost know that it can be simplified because you realize that you don't have a handle on maybe this part of classes or this part of functions, and you're trying to use it in a way that it might necessarily be designed for, but it still gets the job done. He sort of explains how to prevent yourself from doing that and the best ways to go about it.
whole additional slide and a half, okay, 2 slides for this. This is such an important Don't underestimate the advantages for this.
Really
If you
like
break
this
this out
because
into
you
pieces,
can't
you risk
change the
ordering
tuple, but you
problems.
can convert it
Also,
or copy
you
it.
are making it too atomic, you are losing the ability to chunk your thoughts and to think higher level thoughts. For example, a problem I give when I teach a scientist is I give them the function influence, the influence of one planet over another. All they have to do is plot the orbit of the planet. And you have some people get nice elliptical orbits and other people where it just kind of zigzags away.
Huh.
The ones who get it wrong are the ones who wrote exactly this code, except they didn't use the temporary variables. If the first thing they wrote is x is equal to x plus dx plus t, they're toast at that point. Why? They wrote is x is equal to x plus dx plus t, they're
Yeah,
toast at
because
that
you
point.
need a temporary
Why?
variable. I learned that over here on this file. I'm gonna open it right here. And it's basically a really good, let's see here, swapping variables. So basically what I do here is a really interesting little file. You have these two variables, variable 1, v1, variable 2, v2, and basically what we're doing is we're swapping the value of variable 1 and variable 2 and then swapping them back. So if we run this program, you'll see that what we get is first string, second string, first string. Okay, because what happens is this is first string, so second string, and when we print them, we're basically printing variable 1, variable 2, and the temporary variable. And we set temporary to variable 1, as you can see here, they equal the same. So that when we swap them between each other, you can actually keep track of the data as it's switching between them, because the way that Python works is that the very last sum that you assign a value of to a variable is what it equals. It doesn't keep track of that data over time, or all of the variables that it equals. It only keeps track of the very last variable. The only variable that matters is the very last sum, or the very last assignment. So that's pretty much the variable that gets called when you print. And I learned this from CS Dojo. He's got many videos on YouTube that are great. Really good explanations. He'll teach you a lot of stuff about Python, and I'm sure very many other languages that he's got on there. He used to do a lot of work with Google, so you know, definitely somebody to learn from. Also, if you look here in my link, you can see our Discord, Developers Cafe. If you guys would like to participate in these projects, you can visit this link. And that's our invite code for Discord. And I can answer questions, you can talk to me there, and that's the best way to communicate if you're interested in participating with this channel. And we're not going to just be doing programming stuff, although that's what we're doing right now. It's supposed to be filled with a lot of things, you know, but right now we're just doing a sort of a learning video, because that's what I'm doing, and this channel is about everything that I'm doing at the time. So let's go back to the video.
They've updated the x, and now this one gets computed with the new x rather than the old x. It's a very common problem. The other half of the people who write these temporary variables, how did they know to do that? The answer is they've all been burned by this problem before. The correct answer is this. Do the calculations on the right with the old values of the variable, the old x, the old y, the old dx, dy, take their partials, and then only then update all of the variables. This is of profound importance, not just for scientific computing. I can give other examples where people are doing a simple mortgage calculation with principal and interest and whatnot, and the very first thing they do is update the principal by principal minus equal payment, they're toast because their interest payment's going to be wrong.
Yeah,
The
you have to know
interesting
how to
thing
do
to
basic
me
math before
is
you can
not that they get
program.
it wrong when they program in any language. The interesting thing is I can give them the same problem in Excel, and they always get it right. Why is it that people get it right in Excel and wrong in programming languages? The answer is in Excel, you take all
Syntax.
the state on each row. On month one, here's the current principal, interest, and whatnot. On month two, it's this, and people naturally refer to they take their formulas and they refer up to the previous row. All Excel people do this. Essentially, they are doing exactly this operation. You could view this as what's on the right is referring to the previous row, and what's on the left
Oh,
is
but this
the
is
new
not
row,
Excel.
and that gets iterated. In other words, it's a very natural style of thinking. Please don't write code like that. Write code like that. This is a big deal that we've got it in this language. It will save you from a lot of trouble. Got 1 minute.
Okay, so let's see what exactly this all means. We're gonna go temp x equals x plus dx times t, temp y equals y plus dy. Now I know this just looks like I'm just typing out everything that he's doing, which I completely am, but as you follow through, we kind of discover new things, and I understand enough about the language at this point to where I can sort of like, some of these versions on the video here are for Python 2, a lot of it's for Python 3, and I'm just sort of converting the syntax as I need to. But by no means am I a master expert or anything like that. I'm still learning this language completely myself, but I spent quite a bit of time on it over the few weeks that I've been learning here, and I've gotten quite far. The first thing I did is I went to W3 schools, and I learned over the entire chapter of Python that they have there. It's like 36 chapters, the entire section that they have. And if you want to go ahead and take a look at them, I will probably post a link in the description. They were where I started, and I would recommend that because they give a really good layout, and it's really easy to follow and understand. I definitely could have read the Python documentation, but it just seemed a lot more cluttered and confusing. W3 schools did really well with their layout. So I would definitely continue to go back to them. Another person, I have to get their name right. I don't want to mess this up because they were teaching me so well. It's a really awesome guy, and the big part about it is that it's free, and you can support him by donating. And actually, now that I type that line, I'm going to go ahead and pull him up for you guys. It's probably one of the best resources I've found lately. He doesn't give you anything that crazy. I mean, I'm not gonna overtalk him, but I mean, if you're a complete beginner and you don't know what you're doing, he's a great learning resource, and we're gonna go to him right now. We're gonna go to Mike Dane. That's his name, and if I can click the right bookmark, we'll get there. There. So. And I don't know why that's in my bookmark for Python. I should get rid of the car game. I guess I was trying to learn something about that car game, but it has nothing to do with this game programming, so we're gonna remove it. Yeah, so as you can see, if you click Let's Learn, he's got a bunch of courses. As far as I know, they're all free. SQL introduction here. We got C Sharp, C++, C programming language, Ruby, Python. That's the one I went through. He provides it in a video format. It's really awesome, I think, because you don't have to read if you don't want to read, and he basically walks you through it. And I'm great at watching videos. I don't know about you, but I just love that sort of format. That's how I teach myself, and this gives you a great way to do that. But he does provide a lot of text-based information. You can see here, you can click next, and it'll take you to the next set of chapters that he's got. So if you are on the installation page, it'll take you down to Hello World, and then if you click next, it'll take you to drawing a shape, so on and so forth. And it's a really, really great website. I have no affiliation. I'm just, a person that is logged in and checked out his material and learned a great deal from it. I would say a lot of it, you know, it's just a matter of, you might not learn everything you need to from this one part, but let's say you learn something from W3 schools and they explain it one way, because as we all know, there's almost a million ways to do something in programming. So when you learn it one way, you can be subjected to sort of be stuck in that format. And this is a good way to get outside of that teaching and stop developing bad habits. And if you want to really improve yourself, after going to someone like Mike Dane and learning the basics, and then going to, let's say, W3 schools, and then getting a little bit more of a bigger grasp on it, you can go to a video like this that we're watching right now and learn how to prevent making very, very amateur mistakes in your programming down the road. And it doesn't mean you need to grasp everything that they're teaching you right now. It just means that you need to keep it in your mind, know that that's out there, and then that's part of standard operation procedure, and to get it down and know that that's an important factor in programming if you wanted to make a career out of it. So just a side note there, I wanted to take you guys to that resource because it's a great resource.
Big deal that we've got it in this language. It will save you from a lot of trouble. I've got 1 minute. Efficiency. I'll do efficiency fast. Basically, just don't move data around unnecessarily. Concatenating strings. In my classes, I tell an Aggie joke around this. In order to hammer home, this is quadratic behavior. Don't add your strings this way. Instead, join them. It sounded like most of you knew that already. Go check your code base.
So this makes sense. Let's go ahead and apply it here. We don't want to save that. And also, we have our Fibonacci sequence working, so we're not going to do that right now. I will go back and do that later. Probably still, on stream and everything, but let's do what they're talking about here. So we got names equal Raymond, Rachel, Matthew, so Roger, Betty. Oh my god. If I could just type Roger, Betty, Melissa. And then what else? Judith and Charlie. Right? And so that gives us our, it's not a dictionary, our list, no, our set. Yeah.
And see if your code base knows that. Just saying.
Yeah, so that gives us our set. Still hanging in there. We're gonna minimize that one for now. And then, yeah, so most people apparently are doing this. Names, 0. Oh yeah, look at this. Already a lot of code. And names. And then, basically, okay, I think I see what's going on here. And then, printing the set. So, now, when we do this, this should print off the set of names. Oh yeah. Shit. Oops. Shoot. Oh, interesting. That was really cool. What do we do here? Raymond, Matthew. Awesome. So, okay. So apparently you can also just do this. And that is what they're saying. So, this should do the exact same thing. One line of code, right? That's what we're going for here. Let's keep doing this. Yes, it does, I believe. Let's just get rid of this code here so we can. Alright, so this does Raymond, Rachel, Matthew, Roger, Betty, Melissa, Judith, Charlie. Yes. So that's what we would want it to do. Now what's going on here? S equals name 0 for name and name 1. For name and names, S plus equal plus name. That's probably the proper way to do it. For name and names, S plus equal. Now, I know it's going to print the same thing, but yeah. I just thought it would be interesting to see that. So that's actually pretty interesting. It's going Raymond, and then after that it should be printing the letters out. Yeah, Raymond, Rachel. Very interesting. And of course, if we did name, it would print it out just the same as that, I believe. I'm not sure. Ah, and it just doesn't stop doing it. Okay. Essex's names for name and name. Maybe they wanted it to do that. I'm not sure. It just seems weird that they would have it do that.
Updating sequences. If you see a del 0, a pop 0, or insert 0, you're doing it wrong. I go into customer sites, they say, here's a million lines of code and it runs really slow. Can you make it go fast? As if I'm going to be able to read a million lines of code. But 15 minutes later, I come back and said, I've sped up your code. What did I do? I grepped for these three things. Pretty much everywhere they did a del name 0, a pop 0, or insert 0, they were using the wrong data structure. What's the correct data structure? Deck. Yeah, I did that.
Okay.
Anyway, a deck lets you do you can delete names 0 efficiently, a pop left efficiently, or a pinned left.
Okay, let's see. But now, it should be the same in Python 3. when you type pop, it shouldn't be an issue anymore. But let's see. So we'll go down. Alright, so that's insert. There we go. So basically, these are all the same.
You can delete names 0 efficiently, a pop left efficiently, or a append left efficiently. Decorate.
Maybe he did that. I think that's what they meant to do. Alright. Okay, so. Why? It's not a tuple. Alright, we'll get rid of this. They should do the same thing now. Oh my god. Oh, got you. So, this is the way to do it in Python 3. Because pop Unless there's iPop or something like that. I don't think there's anything like that, so. But
have 6. By the way, if you're grouping by anything else, code base, but a command line argument should take precedence over the environment variables. This kind of code is very common. How many of you have written some code like this ever? Is it the right way to do it? Well, it copies data like crazy. If you want your code to be fast, don't copy like crazy. So chain map has been introduced into Python 3, and it links them all together.
Huh. Don't remember chain map coming up.
Cool. No questions. It's 1, brackets 2, brackets 3. You know what's going on. Temporary variables. How did later I come back and said I have to sped up your code? What did I do? So remember the Spider-Man rule: with great power, pop left efficiently or a append left efficiently. Decorators and context managers, I have no seconds left, but we're going into break time. Oh, 5 minutes? Woo! We have time for decorators and context managers, which completely rock. We're out of novice territory and into really good stuff. These are fantastic tools for refactoring your code, but good naming is essential because it provides macro-like capability, meaning you can hide all kinds of awful actions behind the macro, or you can be very clear. So remember the Spider-Man rule: with great power comes great responsibility. All right, so I want to factor out some administrative logic. The business logic here is opening a URL and returning a web page. The administrative logic is I'm caching it in a dictionary. That way, if I go look up the same web page over and over again, I just simply remember it. You'll see code like this all over the place in Python, where someone's trying to cache their lookups. What I don't like about it is it mixes the admin logic with the business logic, and it's not reusable. Simple fix: add cache. It's actually the LRU cache in Python 3. I have backported it for people who want to scan for the backport. You can start using it today. That said, these things are pretty easy to write on your own. So I really want to demonstrate the decorators here less than what I've written. This is reusable. I can put at cache in front of any pure function, a pure function being one that returns the same value every time you call it.
Huh. Huh.
Random.random, is that a pure function? No, because it gives a different value every time you call it. Pal, is that a pure function? Yep, same answers every time. The business logic has been separated from the admin logic, and I've gotten reusability. The way I write it is with a simple caching decorator.
So if I do this, I can access that function. Oh well, I might not have the libraries to use that. Or it's not compatible for Python 3, or I'm typing
It only takes a few lines. I would like for your utilities directories to be full of little tools like this so that elsewhere in your code, you put add cache and the problem is solved. Factoring out temporary context for decimal. So we copy the context, change the decimal precision to 50, do a calculation, and restore the old context. This is saving the old, restoring the new. That happens over and over again. There's a better way. With local context. The context manager here makes a copy of the context, puts it in place, does the calculation, restore it. Which is easier to get right, the first or the second? Second one, it has reusable logic. Pretty much anytime your setup logic and teardown logic get repeated in your code, you want a context manager to improve it. Okay, the traditional code base, especially if you're doing this sort of thing all over the place. Okay, the traditional way to open and close files, everybody knew they were supposed to do it.
Oh.
They wouldn't do it. You had to do the try and the finally, and C Python closes for you anyway. But the simple way, the new way is beautiful. What did the with statement fast for you? Knew they were supposed to do it. They wouldn't do it. You had to do the try and the finally, and C Python closes for you anyway. But the simple way, the new way is beautiful. What did the with statement factor out for us? It factored out the setup logic and
Now, should I add text file to the root?
Teardown log. Go fix it. Do a try finally. How to use that one. Already? Does your code base know?
People are stupid. Alright, so let's see. So let's see if this ends up working. And we go data.txt, and that should actually do it so that it's working. Yeah, I think that will do it. I wanted to go here and then add a file called data.txt. So busy out here. Sorry for all the noise, guys. Now, in retrospect, I might realize this was probably not the best video, but you gotta start somewhere, so I'm going to do that, and I'm just gonna continue uploading, and, you know, some videos will be better than others, you know, but not everything in life is fun and exciting, but life can be fun and exciting. The wait time on this file is definitely not fun and exciting. What just happened? Great. I had documents open and now it's not. Let's do this again. Oh, almost crashed. We can do it, little laptop. How hot are you? Sort of hot. Not that hot. We could go inside. But it's so nice out here. I mean, I'd hate to go inside on such a beautiful day. Literally, look at this day. And from Nevada. Scaring the cars. They're all like, what is he doing? Oh my god, drive away. Yeah. So, let's go inside. Ooh. Hey, dear, could you help me with the door, please? Thank you so much. We made it inside. Oops. Okay, it's not hot. Good.
Did you have fun?
I'm still streaming. But yes, I did have fun outside. It's really nice out there, actually. So much, like, fresh air and everything. It's way better than it's been recently. It's been really windy. Alright, so we're back inside. After a few hours of, whoa, inside, or outside fun. Yeah, it's okay. It's not gonna be too loud. Thank you. Got you. My quality in stream status is the same as my financial situation. Poor. Yeah. I guess I'm just gonna have to figure out how to fix that.
Too bad when it speeds up, it doesn't say
So.
much.
Yeah, right. It's okay though. I'm looking for where it says well, you know. There we go. So for this whole time, I've just been capturing my
Whoa.
Darn. Well, hi guys. Now I know what I'm doing. I'm not a total newbie. Yes, I am. You know it. I cannot believe I did not have that going correctly the entire time. Oh well. It's okay. So this entire time I had the display capture and video capture going, right? And unfortunately the display capture was on top of the video capture instead of the other way around. So nobody could see that I was talking, like, you know, with a video on.
Oh.
Yeah, so that's what happens when you don't know what you're doing, guys. It's okay, though. I've been doing this for an hour with no video. Except me. Except for just... But it's okay.